For as long as humans have walked the earth, we have looked up at the sky and stared in absolute awe at two of the most dramatic celestial events nature has to offer, the solar eclipse and the lunar eclipse. For ancient civilizations, these moments were not just visual wonders, they were omens, messages from the gods, or signs that the world, as they knew it, might be coming to an end. Tribes in Africa, emperors in China, philosophers in Greece, and astronomers in the Middle East all wrote about these strange darkenings of the sun and the moon, crafting myths and stories to explain what they could not yet understand with science. Today, we no longer fear eclipses, but we still stop everything to watch them because they remind us of the incredible order and precision that governs our solar system. In this video, we are going to dive deep into the pure, uncomplicated science of how solar and lunar eclipses form, why they are so rare, and what makes each type of eclipse unique. This is not a lesson filled with complex jargon or hard-to-follow math. This is a story of three celestial bodies, Earth, the Moon, and the Sun, moving in perfect harmony to create light and shadow on a cosmic scale. Let us start with the most basic truth you need to know. Eclipses only happen when three things line up exactly right. There is no luck involved, no random chance, just strict orbital physics that has played out for billions of years. First, let's talk about the players in this cosmic performance. The Sun is our star, a giant ball of hot glowing plasma that provides all the light and heat for our solar system. It is about 109 times wider than Earth, and it sits at the very center of everything we orbit. Earth is our home planet, a rocky sphere that spins on its axis every 24 hours and circles the Sun once every 365 days. The Moon is Earth's only natural satellite, a rocky, airless world that orbits Earth roughly every 27 days, and it is tidally locked, meaning we only ever see one side of it from our planet's surface. For an eclipse to occur, these three objects, Sun, Earth, Moon, must fall into a straight or nearly straight line. That is, the non-negotiable rule. If they are even a little bit out of line, no eclipse happens. Now, you might be asking, if the Moon orbits Earth every month, and Earth orbits the Sun every year, why don't we have a solar eclipse and a lunar eclipse every single month? That is, the next critical piece of the puzzle. The Moon's orbit is tilted. The Moon does not circle Earth on the same flat plane that Earth uses to orbit the Sunday. Instead, its orbit is tilted by about 5 degrees relative to Earth's orbital plane, which astronomers call the ecliptic. That small 5-degree tilt is the reason eclipses are rare events. Most months, the Moon passes above or below the line of sight between Earth and the Sun, so no shadow falls on Earth, and no shadow from Earth covers the Moon. Only twice a year do the orbital planes line up, creating 2 eclipse seasons where eclipses can happen. Even then, the alignment has to be perfect for a total eclipse to form. Most of the time, we get partial eclipses or no eclipses at all during these seasons. This delicate tilt is what makes eclipses feel like special gifts from the cosmos, not everyday occurrences. Let us begin with the solar eclipse, the event that has terrified and fascinated humans more than any other celestial sight. A solar eclipse happens when the Moon moves directly between the Sun and Earth, blocking the Sun's light from reaching our planet's surface. Think of it like holding your hand up in front of a flashlight to block the light from hitting a wall. Your hand is the Moon, the flashlight is the Sun, and the wall is Earth. When the Moon is perfectly in the middle, it casts a shadow onto Earth, and anyone standing inside that shadow will see the Sun disappear, either partially or completely. There are 3 main types of solar eclipses, and each one depends on how the Moon's shadow falls on Earth and the distance between the Moon and Earth at that moment. The first type is the total solar eclipse, the most spectacular and sought-after eclipse of all. This happens when the Moon completely covers the bright face of the Sun, turning day into night for a few short minutes. During a total solar eclipse, you can see the Sun's faint outer atmosphere, called the corona, glowing like a silver halo around the dark silhouette of the Moon. This is the only time we can see the corona with the naked eye, making total solar eclipses incredibly valuable for astronomers. The second type is the annular solar eclipse, which happens when the Moon is at its farthest point from Earth in its orbit, called apogee. At this distance, the Moon appears smaller in the sky, so it cannot cover the entire Sunday. Instead, it leaves a bright, ring-shaped annulus of sunlight visible around the Moon's edge. This is often called the Ring of Fire eclipse. The third type is the partial solar eclipse, which is the most common solar eclipse. This occurs when the Moon only covers part of the Sun, so only a portion of the Sun's light is blocked. Partial eclipses can be seen over a much larger area of Earth than total or annular eclipses. but they are far less dramatic to watch. It is important to note that you should never look directly at a partial or annular solar eclipse without proper eye protection. The sun's intense light can permanently damage your eyes in seconds. Only during the brief total phase of a total solar eclipse is it safe to look up without protection. And even then, you must stop looking as soon as the sun's bright edge reappears. Now let us shift our focus to the lunar eclipse, a softer but equally beautiful celestial event that happens when Earth moves between the sun and the moon, casting our planet's shadow onto the lunar surface. Unlike solar eclipses, lunar eclipses can only happen during a full moon, because that is the only time the moon is on the opposite side of Earth from the sunday. When Earth blocks the sun's light from reaching the moon does not just disappear into darkness. It often turns a deep, rusty red color, which is why lunar eclipses are commonly called blood moons. This red color comes from Earth's atmosphere. As sunlight passes through our planet's thin layer of air, all the blue and green light is scattered away, leaving only red and orange light to bend around Earth and fall onto the moon. It is the same effect that creates red sunsets and sunrises here on Earth, just projected onto the surface of the moon. There are also 3 types of lunar eclipses, each defined by how much of the moon falls into Earth's shadow. Earth's shadow has 2 parts: the umbra, the dark, central part of the shadow, where all sunlight is blocked, and the penumbra, the faint outer part of the shadow, where only some sunlight is blocked. A total lunar eclipse happens when the entire moon passes into Earth's umbra, turning fully red. A partial lunar eclipse occurs when only part of the moon moves into the umbra, so only a portion of the moon turns red, while the rest stays bright. The third type is the penumbral lunar eclipse, which is very subtle and hard to see. This happens when the moon only passes through Earth's penumbral shadow, dimming the moon slightly, but not creating any dramatic color change. Most people never notice a penumbral lunar eclipse unless they are actively watching the moon with a telescope or binoculars. Unlike solar eclipses, lunar eclipses are completely safe to watch with the naked eye, no protection needed, and they can be seen from anywhere on Earth where the moon is visible during the eclipse. This makes lunar eclipses far more accessible to people around the world than total solar eclipses, which only cover a narrow path on Earth's surface. For thousands of years, humans tried to predict eclipses using careful observation and pattern recognition, long before we understood the orbital science behind them. Ancient Babylonian astronomers were the first to record eclipse patterns and discover the Saros cycle, a period of about 18 years and 11 days, where eclipses repeat in nearly the same pattern. This cycle allowed them to predict when eclipses would happen with surprising accuracy, even without knowing about orbital tilts or celestial alignment. Today, NASA and space agencies around the world use advanced satellites, telescopes, and computer models to predict eclipses down to the exact second decades in advance. We can map the path of a total solar eclipse years before it happens, telling people exactly where to go to see the full effect. Eclipses are not just beautiful to watch, they are also critical tools for scientists. Solar eclipses let us study the sun's corona, which is otherwise too dim to see against the sun's bright surface, helping us learn more about solar, wind, magnetic fields, and space weather that can affect Earth. Lunar eclipses help scientists study Earth's atmosphere and the moon's surface composition, giving us new data about our closest celestial neighbor. Every eclipse is a chance to learn more about our solar system, and each one reminds us of how small we are in the vastness of space, yet how connected we are to the cosmic forces that shape our world. When you watch an eclipse, whether you are standing in the path of a total solar eclipse or gazing at a blood moon from your backyard, you are witnessing an event that has remained unchanged for billions of years. The same alignment that created eclipses for the dinosaurs is the same alignment that creates them for us today. It is a timeless, universal event that connects every human being who has ever looked up at the sky in wonder. We no longer need myths to explain eclipses, we have science, and that science makes these events even more magical. It shows us that the universe is not chaotic or random. It is governed by gentle, precise rules that create some of the most breathtaking sights we will ever see. The next time you hear about an upcoming eclipse, take a moment to step outside and watch. Pause, look up, and remember that you are seeing the sun, earth, and moon dance in perfect alignment, a cosmic performance that only happens when the stars and the planets and moons align just right. This is the wonder of our solar system. This is the beauty of astrophysics, and this is the magic of eclipses. Please like, comment, share, and subscribe to the channel.